Hello, Precalc. Welcome. Today is Thursday, May 4th, Star Wars Day. May the 4th be with you. Um, it's just me today. That's totally okay. We haven't met in a long time, so I'm just gonna kind of recap, run through some stuff, so that we can um we've got a lot to kind of review and go over. So let's go ahead and take a look at Schoology and just sort of what's been going on since quarter 4 started. Okay. As always, if you have questions with the pacing guide, or if you have questions or not sure what to do, look at the pacing guide. Again, that's kind of going to help you a lot working through this stuff. It is mid-quarter coming up. In my class for math, again with Mr. Larson, it's okay if you turn in stuff after mid-quarter. I'll still take it. You'll still get points. Other teachers, it may be different. So make sure you check with that individual teacher to see sort of what the deal is. We really sort of finished up our unit on limits. And again, so I'm going to focus kind of more on our new unit with derivatives. As far as with seniors, because half our class is seniors. So seniors, you do sort of have like you graduate early. So again, as we move forward, you will not necessarily do the last unit that the underclassmen will. So seniors, you've got this derivatives unit, you've got this Riemann sum unit, and then the final exam. Underclassmen, you've got the derivatives, Riemann sum, antiderivatives, and then the final exam after that. So I'll make sure to clarify that and talk about that more when it becomes a little bit more relevant. But just again, a bird's eye view, 10,000 foot view of what we've kind of got going on. So we kind of start this unit talking about secant, tangent, and sort of the limit definition of a derivative. So again, a derivative is kind of like how fast are we changing from one period to another? How much are we moving? And so as we know from, geometry, secant lines touch twice. They touch our curve twice. Tangent lines only touch them once. And sort of as this secant line gets closer and closer and closer and closer, eventually it turns into the tangent line. We can also think about secant as the average rate of change or simply the slope. And so there are lots of ways. We've talked about slope for years. There's lots of ways to calculate the change in y over the change in x, y2 minus y1, looking at functions, taking the y outputs and the x outputs. Lots of different ways to think about the same idea, which is slope. So the average rate of change is of a function between 2 points, and the slope between 2 points are the same thing. Like we said, a tangent only touches once, and this is called the instantaneous rate of change. The slope of the tangent line at the point of the function is equal to the derivative of the function. So tangent line equals instantaneous rate of change, which equals the derivative. So if we look at this example, let's see what happens as the 2 points used for secant line get closer to one another between the 2 points and the x-axis. Again, we can see we've got our change in x, our change in y, and as it gets closer, our change in x becomes approximately 0, which creates our tangent line, or also known as the derivative. Watch this again, moves closer, becomes approximately 0 right there. So let's see here. Again, kind of just reiterating that what is a derivative? It's the slope between the 2 points. And again, we're looking at the limit as it exists, which is where the tangent line is, and that gives us our instantaneous rate of change. And we can find increasing and decreasing derivatives. So that's kind of, again, we sort of like ease in a little bit into what is a derivative, talking about a derivative. And so we are looking at difference quotients, which again, this is kind of our main function here. Limit h approaches 0. Every time I see an h or an x, I'm going to add a plus h in there. And then again, looking at it. So if we look at this example, let's look at this one. So I want to find the limit as, and so what I'm gonna do every time I see an x, I'm gonna plug in an x plus h inside. And as I work through, again, this is just doing a lot of algebra, a lot of multiplying and simplifying and combining like terms. I can end up with something that looks like this. See if I can move this out a little bit. Can't really see it. There it goes. And so what ends up happening is I take f of x plus h minus f of x. I ended up getting 3x squared plus 6x minus 4 plus 3h squared plus 6xh plus 6h. 3x squared plus 6x minus 4 is exactly what I started with. So essentially, when I do this, these two are going to cancel each other out, and all I'm left with is 3h squared plus 6xh plus 6h. And now again, as I set that up, I still have to include my h on the bottom. That comes from my initial equation. And so I'm saying, all right, let's go and work through 3h squared plus 6xh plus 6h. If all my terms have an h, I can cancel that out from the denominator, and I'm left with 3h plus 6x plus 6. Now I go ahead and focus on the limit as h approaches 0. Every time I see an h, I'm going to plug in a 0. 0 plus 6x plus 6. So my slope or my difference quotient is going to be 6x plus 6. So again, the limit, h approaches 0. All this stuff is going to end up giving me 6x plus 6. Okay, let's see here. Let's look at there's a problem in our Class Connect that I want to, our Class Connect assignment that I want to look at. And it says find the difference quotient of f of x equals 3 minus 1/4 x. Okay, so I'm gonna again I'm just gonna write my initial equation, limit as h approaches 0 of f of x plus h minus f of x all over h. So again, I'm going to keep this out here, but I'm going to focus on f of x plus h. And every time I see an x, I'm going to write an h. So 3 minus 1/4 parentheses x plus h. And then I'm going to write the exact same thing. I'm not changing the second part at all. And I'm going to divide it by h. All right, let's keep simplifying. So I've got some simplifying right here I need to do. 3 minus 1/4 x minus 1/4 h minus, and again, this should really be in parentheses because of my initial equation. So minus 3, if you distribute this here, it becomes a positive plus 1/4 x. Looking for things that either simplify or cancel out. Positive 3 minus 3, negative 1/4 x plus 1/4 x. All I'm left with is negative 1/4 h, negative 1/4 h over h. Again, I can see, hey, I've got h on the top, h on the bottom. Therefore, this is going to equal the limit as h approaches 0. I have nothing. I have no h's left. Therefore, it's not going to move. It's going to stay exactly the same. All right, so let's go to Schoology. Just want to review where to find this. Oh, I'm going to share some practice. So again, if you want to pause the video, you can try this practice on your own. Let's see, it's hard when no one joins, but I bet I can zoom in a little bit. So there's a difference quotient. Another one, again, just pause, try on your own. Just going to scan through them. A instead of X doesn't really matter too much for that formula. Basically the same thing. Don't worry about this one. All right, that's all we're going to, so just look at those 5. And for Schoology, okay. Class Connect assignments folder, Class Connect right here. This was that, what we talked about at the beginning. Go ahead, fill in the blank where appropriate. And this is the example that we just did. Let me know if you have any questions. Again, keep working hard. Seniors, you know, you're so close. Keep working hard. Underclassmen, you're doing great. We've got a couple more ideas. Again, this is really sort of, I would say, introduction to calculus and less of pre-calc. It's really like kind of starting to look at those calculus ideas. We will have a Class Connect next week. I will see you then.